Alright guys, welcome to this page of the notes, and again what we're going to be doing is we're going to use the rational zeros theorem to create a list of all possible rational zeros for this polynomial, and it's really pretty simple and straightforward, so let's just jump right into it. You first need a naught, which is the coefficient, the constant at the end, in this case that's a 10, but I need all of its factors. Well, the factors of 10 are plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. So that's all the factors of 10. Then my an is a 3. But I need all of its factors. And again, the factors of 3, we already did this one. It's plus or minus 1 and plus or minus 3. Now what I'm going to do is I'm going to write my list, a naught over an, and I'm just going to systematically work my way through to make sure I get all the possibilities. 1 over 1, 1 over 3, that's it. Then 2 over 1, 2 over 3, then 5 over 1, 5 over 3, then 10 over 1, and 10 over 3. Simplify them when you can, so let's go ahead and do that. 1 over 1 is just going to be a 1, so that's plus or minus 1. 1 over 3 is going to be 1/3, so plus or minus 1/3. Let's see, 2 over 1 is going to be a 2, so plus or minus 2. 2 over 3 would be 2/3, so plus or minus 2/3. 5 over 1 is going to be a 5, so plus or minus 5. 5 over 3, 5/3, so plus or minus 5/3. 10 over 1 is going to be plus or minus 10, and the last one, plus or minus 10/3. Again, apologize, I'm squeezing. But anyway, there it is. There's my list. I don't have any duplicates. I've simplified them as much as I can. And so here's what we know. My polynomial is a third-degree polynomial, which means I have 3 zeros. If one of those zeros is a rational number, it's somewhere in this list. Now look at how many options I've got. 2, 4, 6, 8, 10, 12, 14. I've got 16 numbers in this list. But the polynomial only has 3 rational zeros, right? So not all of them are actually going to be zeros. The point is this: if the polynomial has a rational zero, it's somewhere in this list. We'll worry about finding it later. Let's do another one. Now, I'm not out to kill you guys. I don't want to make these problems harder than they have to be. So eventually what we're going to do is we're going to have to work our way through the list to find the actual rational zero. So in those kinds of problems, I am not going to give you something where you have 16 possibilities. It would take forever to go through each of these possibilities until you find one that works. So what I'm actually going to do is I'm going to give you problems that are a little bit shorter lists. And this is one of the ways that I'm going to do it. Hopefully you can recognize, if not already, my a naught is equal to 24. My an is equal to 1. This is a big deal. The factors of 1 are just plus or minus 1. So let me work you through this here, if you don't see it already. This is really, really, really awesome. And generally, if you're taking this class with me, generally what I'm going to do to you to just make the problem so that you still have to solve the problem and do everything I want you to do, but without making it overly complicated. So the factors of 1 is just plus or minus 1. The factors of 24. Now I recognize we've got a lot of them. It's plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, and plus or minus 12, right? Those are my factors of 24, but here's what happens. Remember, my list is going to be a naught over an. But what is an? Well, the factors of an are plus or minus 1. That's my denominator. Well, what happens anytime you have a 1 in the denominator? Yeah, it's just equal to the numerator. Anything divided by 1 is itself. So it turns out whenever the leading coefficient is a 1, your list is just a naught, right? Because 1 divided by 1 is 1, 2 divided by 1 is 2, 3 divided by 1 is 3, 4 divided by 1 is 4, right? Whenever that leading coefficient is a 1, your list of possible rational zeros is just going to be whatever a naught is. So my list, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, and plus or minus 12. Now again, I still have a lot of possibilities. 2, 4, 6, 8, 10, 12. Still 16 possibilities for a polynomial that has at most 3 zeros. So not all of them are going to be zeros. In fact, none of them may be zeros. And there's still a lot of possibilities to work through here. But nonetheless, you can see I made the problem a little bit easier by making that leading coefficient a 1. Let's do one more. I got one more for you here on the next page. That's going to be much, much more like what you can expect to see from me when it comes to these problems. Again, right away you recognize the leading coefficient is a 1, which means that an is equal to 1 and its factors are plus or minus 1. What that tells you is your list is just going to be whatever a naught is. Well, a naught is 3, which means the factors are plus or minus 1, plus or minus 3. So a naught over an is equal to a naught. It's plus or minus 1 and plus or minus 3. Okay, now here's why this is much more like what I'm going to ask you to do. You only have 4 possible options, which means if this polynomial has a rational zero, you only need to check 4 numbers. Plus 1, minus 1, plus 3, and minus 3. And honestly, guys, that won't take you that long to do, to run through those 4 options to check and see if one of them works. So this is very, very much like the kinds of problems I'm going to give you when you've got to work your way the whole way through to make the list and then actually find a rational zero by working your way through the list. I'm going to give you a short list. I'll know that you know how to do the problem without killing you by giving you a list that's got 16 numbers in it, right? We don't have to work that hard. So anyway, here's the point. You find the list. You know that one of those guys is going to be a rational zero if you have any. And we'll work through systematically checking them to find the rational zero that works. So head on over to the next page of the notes, and we'll actually begin to work on some of these awesome problems using both the factor theorem, the rational zeros theorem to find all the zeros of a polynomial. I'll see you guys on the next page.